Hello everyone, welcome to this session on Numpy indexing and slicing. In this session, we will learn how to access individual elements and group of elements from Numpy arrays using indexing and slicing technique. These concepts are very important because most data manipulation operation in Python and data science depend on selecting the required data efficiently. By the end of this session, you will be able to perform indexing and slicing on both one-dimensional and two-dimensional Numpy array. Let's get started. First, we are going to discuss about index and subset of array for one-dimensional. Before learning slicing, let us understand indexing. In NumPy, indexing starts from 0. The first element in NumPy array has index 0 and the second element in the NumPy array has index 1. Similarly, the last element has an index equal to length of array minus 1. In NumPy array, by using index number, we can access the specific element. Consider the example for both indexing and slicing. Consider the single dimensional array B. It will be having a 3 element 3, 5, 7. So indexing will start from 0. So 0th position will be the first element of the array and first position will be the second element of the array and second position will be the third element of the array. So if I am referring B of 0, so if I am referring B of 0, which means 0th position value, it will be written. So in 0th position, we will be having the value 3, so it will be written. Then if I am accessing B of 2, it will be written the second position value, so 7 it will be written. So in this example, this 7 will be the last element of the array. So I can also access B of minus 1. So minus 1, it will be representing the last position of the array. So in this example, if I am giving B of minus 1, it will be referring the value 7. So see this example here, B of minus 2. So B of minus 2, which means it will be referring the second element from the last position. So from the last position, second element will be 5. So this element will be written. To perform slicing, we have to use this syntax array of start colon, stop colon, step. So start, which means index position to begin. This will be included in output. Stop, which means index position to end. This will be excluded. Step, which means number of element to skip, or we can say how many steps we need to move. Consider the example B of 0 colon 2 colon 2. So this 0 will be the start position, this 2 will be the stop position and this 2 will be the step position. So 0 will be the start position. So B of 0, which means it refer the value 3. So start position will be included. So this will be included in output. Next will be the stop position. Stop position will be 2. So 2 referring 7. So this part will be excluded. We can access only 0, 1. But here we also mentioning step position 2. So step position 2, which means it will be moving 2 steps. So after accessing the element index position 0, it will move 2 steps. So 1, 2, it will move here. But defaultly in this example, second position will be the end position. So it will be written only the value 3. Then see the example B of 0 colon 2. So 0 will be the starting position and 2 will be the end position. So we can access element of 0th position and first position value alone we can access. And see the example here B of 1 colon. So B of 1 colon, so 1, which means start position and we are not mentioning an end position. So which means starting from first position to until the end of the array, all element we can access. Same way, if I am not mentioning any start position, from 0th position we can access the element. Let us understand this better by using this example. Okay, I am creating one dimensional array by using np.array of and store it in a variable a. Then I am printing the array a. So this single dimensional value will get printed. We can see indexing operation. So if I am accessing a of 0, it will be written the first value in the array. And if it is a of 2, it will be written the second index position. So this is 0, 1, 2. So this 30 will be written. Next, see negative indexing. So if it is minus 1, it represents the last position of the array. So it will be written the value 50. And a of minus 3, which means it will be written third element from last position. So this was the third element. So it will return 30. Next we can see slicing. So slicing in this example here we only mentioning start position and stop position. So 1:4. So it start from 1 and we have to end before 4. So we can access the position 1, 2, 3. This part alone we can access. So this 20, 30, 40 these alone get written. Then next we are going to see about slicing with step. A::2. So here we are not mentioning any start position and stop position. We were mentioning only step position. So we are not mentioning any start position. Then we can start from 0 index. And we are not mentioning any end position. We can access until at the end of the array. But here we were mentioning step position, so we have to move 2 step, right? So starting from 0 we have to move 2 steps, so this will be included. After this I have to move 2 step, so 1 2 30 will be included. After this I have to move 2 step, 1 2, then this 50 will be included. After this if I am moving I will go to out of range, so 10 30 50 alone will get referred. Then reverse slicing, so A:::, so here also we are not mentioning any start or stop, but instead we were representing -1. So if it is a negative thing we have to start from end of the array. So here step position will be -1, so it will move one step backward. So it start printing from last position of the array and it move one step backward, so it will all element will get referred. Then by using this table you can refer different option for NumPy slicing. Next we are going to see about indexing and slicing for two-dimensional. So for two-dimensional, consider the array. See, it has 3 rows and 3 columns, right? It's look like a matrix. Okay, so first we can refer for indexing. So C of 0 comma 0, which means 0th row and 0th column. So 0th row and 0th column, it refer the value. The value will be 1. The same way C of 2 comma 0, which means second row 0th column, so the value 7 will be referred. And if I want to refer last row, I can use -1 also. So if it is -1, I am referring last row. And for column, if I am using -1, it will be referring the last column. And see the example for slicing here. C of 1 comma 1 colon. Okay, so 1 comma 1 will be representing for row, colon, column we are not representing anything. So 1 comma 1. So first row, first column, which means it start from here. We are not representing anything for column. So all values in this row will get printed. So 9 5 will get printed. And see the example here, C of 1 colon comma 1 colon. So this 1 colon mentioned for row range, this 1 colon mentioned for column range. So this row range 1 colon, so here it start from row 1 until the last row. So these two row we can access. The same way 1 colon, this is for column range, start from column 1 until last column. So these two column we can access. So these thing alone will get fetched. So this 9524 alone, the value alone will get referred by using this. Then C of colon -1 comma colon -1. So this colon -1 for row, this colon -1 for column. So this colon -1 for row, so what it will do, it select all row except last row. So it select first two row. The same way this colon -1 for column, it will select all column except the last column. So this first two column will get selected. So this part will get discarded. So this thing alone will get printed. This 1689 alone will get printed. Let us understand this better by using the following example. So I am creating two-dimensional array by using np.arrayof. I am creating two-dimensional array and store it in a variable a. Then I will be printing the array a. First we can see index operation. Okay, so here a of 0 comma 0, which means 0th row and 0th column, the element will get referred. So 0th row 0 column, which means the value 1 will get referred. Then a of 1 comma 2, which means first row second column. first row, second column. So this is zeroth column, this is first column, this is second column. So the value 6 will get referred. And see here a of minus 1 comma minus 1. So this minus 1 represent last row, and this minus 1 represent last column. So the value 9 will get referred. Then we can see for row slicing. If it is a row slicing, then we have mentioning only the thing for row, we are not mentioning anything for column. So see here a of 0 comma colon, so we are mentioning only for row. So this 0 is for row, so 0 means it will be representing the 0th row, first row. And see next example a of minus 1 comma colon. So here also we were mentioning only for row minus 1. So minus 1 representing last row, we are not mentioning anything for column. So this example for row slicing. Next we can see for column slicing. If you are going to perform column slicing, we are not mentioning anything for row. See this example a colon comma 0. So for row we are not mentioning anything, and for column we are mentioning 0, which means it will be accessing 0th column. And see here a of colon comma 1. So here also we are not mentioning anything for row. Here we were mentioning 1, so this is for column, we can access the first column. Next, if I want to print submatrix slicing, which means I can use a of 0 colon 2 comma 0 colon 2. This is for row, this is for column. So here this is starting value, this is ending value. For column this is starting value, this is ending value. So for row I can access 0th row first row. For column I can access 0th column first column. So these part alone will get printed. Next we are going to see slicing with step. So see here a of colon colon 2 comma colon. So this is meant for row, this is meant for column. So column we are not mentioning anything. For row there is no start value and stop value, but we have step value, which means it will move 2 steps. So it's so if you are not mentioning any start value, it start from 0th row. After this I have to move 2 steps, so I will be moving here. So this 1 2 3 and this 7 8 9 alone get printed. And see the next example a of colon comma colon colon 2. Here we are not mentioning anything for column, we are row, we are mentioning only for column colon colon 2. So there is no starting column and ending column, but we have step, right? So it start from 0th column and it will move 2 step. So last column it will move. So 1 4 7 3 6 9 alone get printed. Next we can perform reverse slicing for rows and column. So if we are going to perform row, this was the syntax a of colon colon minus 1 comma colon. So for column we are not mentioning anything. So colon colon minus 1. So minus 1 in the sense that that is from last position, it will from last row it will get printed, that is last row become the first row, and this mid row become the mid row here, and this first row become the last row here. So this is reversing row. And see the another example for reversing column a colon comma colon colon minus 1. So it will be representing from last column. So this last column will be the 0th column, and this mid column will be the first column, and this first column will be the second column. Then this is additional slicing operation for 2D array. Refer this table. I hope you will be understanding better about indexing and slicing for one dimensional and two dimensional array. Thank you for watching.